I'm going to start off part 2 showing this the nomenclature of this map here, north base map R2, and here you see 1 inch equals 10 feet on this grid, okay, and this is a 1 inch grid. And the crew, everyone wanted to check out R2 very thoroughly. R2 was our main target spot, and I said, well, I do want to shoot some lines in R1, and I didn't have any volunteers hardly that wanted to go into R1. And as it ended up, I had only one technician that I talked to that I took out with me to shoot some lines in R1, and the machine messed up that night. One of the cable sections had gone bad, and I'll elaborate on that a little bit more later, of what happened that night and why things changed so dramatically. And this is the year MM 2000. So I'm going to show next here some of my notes. I had a handheld recorder, and I would speak into it as the lines were being shot. See, R2 1 meter, R2 2 1 meter, etc., etc. And you can see how I took meticulous notes, and I would go back when I got home, or the next morning I would type into my computer and print out whatever I had taken notes of. And this is all I can find are these 3 pages. I can't find the rest of them, and I don't know where they're at. I'm just going to scroll down. You can read them by pausing if you wish to. It's just notes of where the certain probes were. Probe 12 is approximately 7 feet from the flat stump, so that I could go back out and accurately, as best I could, relocate the direction of the lines with the topography and the profile of the topography, and go at it from that angle. And all of this was done at night, so that's one of the reasons why I wanted to take such meticulous notes. Here's page number 3 here. And now we're getting into R1. Some of the lines in R1. That's just for reference. I'm showing you here a shot of my wall map. And you can see that if 1 inch equals 10 feet, that this covers, you know, a couple hundred feet or so. And you'll see here, this is the edge of the R2 ravine here. This is all on the eastern side, northeastern side of R2. And this is what we call the funnel bowl. Now, whether this is man-made, it could be, because down here at the edge, where it meets with the edge of the bluff, the ledge here, there's a hole cut and a mantle over it, carved over it, and it's definitely ancient. So when the water flows down into it, it kind of forms a whirlpool going down into the stream bed below, which someone in ancient times could have easily taken a shower there. But it's probably, maybe 15, 18 feet or so. You can see here's, you know, and it's probably about, I would say, maybe 8 or 9 feet deep. And this is the little dry bed that goes into it. And here is where I chose to do most of our lines, because I had already checked this in 1997, and we already knew that there was an anomaly there. But being more familiar with the equipment, having better technicians, and this time around more experienced, I felt like we were ready to shoot it, and we did an excellent job. This is like a standard map just to show where anything could be. These are Roman numerals down here at the bottom, which is made to confuse, and these are Latin and archaic Punic letters here for the nomenclature to actually figure out where these lines were. And some of the lines that are bent just so that the probes will come out correctly on a flat grid. See, like this little rise here is only there because the ground goes upwards. If the line is straight, that means pretty much there wasn't very much topography to it. But like right here, this is over a hump. So I have to kind of swing the line around. And I'm going to show a blow up here that shows a little bit more detail. And as I explain the lines, I'm going to be showing how that line was shot. Now, the highlight in the purple shows where all of the super high numbers in the data translation occur at, such as that right here, right here, right here. So it's very possible that all of this has to do with a cavern system because of the way that it comes out in the grid. This is line R2, 1 meter. And you can see here, now at a 1 meter line, the line is like 92 feet or something like that. And you're going down probably here, maybe 5 meters at the, here at the most. But your definition here is probably going to be around 15 feet into the subsurface here. And all the settings are here. Everything is here. So what this is showing you is that there's no tampering with the data. Okay? There's nothing made up. There's nothing to trick the machine. And like I showed you earlier in the previous video, that the machine works solid again and again over the same spot. So what we're looking at is these high numbers. Now remember, anything like 1700 or so is an opening. And you see all this. Now we can tell that these super high numbers here, here, and over here, that is that's actually surface interference. And it's easy to tell that. That can be rat holes, that can be this or that. And also remember that the first meter on a 1 meter line does not show up in the printout. So at 1800, 1750 or so, somewhere along in here, all of this yellow here and this brown and this yellow surrounded by this, that is an opening. And these blue circles here are what Marcus. Now Marcus's father helped design the machine and the software, and the machine is rented out of Austin, Texas. And he assured, when he saw those, he just flipped out. He goes, these are what they call joules. And he said this occurs over a known opening, a cavity, because the resistivity congregates on top of it. Because I told him, I said, I can't understand how come we got such low water readings, and I know there's no saturated clay here. What is that? He said that is a reflection of all of the resistivity readings coming to the same spot over a room. So what this is showing is there's a room here, and a room here. Now remember, we're looking for 13 crypts in the side of this hill. Now I'm going to show you here on this map where 1 meter goes. Starts right here, close to the edge of the bluff here, and it goes out this way, up to the northeast. This is 1 meter. This is 2 1 meter here. And this is 3 1 meter. And my purple highlights here are highly discriminatory. This is just what it is on the map. You could connect these. If someone came by and just drew that purple over to here and connected this purple and drew these longer, it would be fine. You would still have the same idea, the same printout. Now we're going to look at R2, 2 1 meter, and you can read all of the settings here, and you can see the topography, the profile here. And here at 1700, boom, what have you got? And look at this over here. Of course, now this is over closer to the edge of the bluff, so that could be a reflection coming off of the edge of the bluff. But that right there looks like 1, let's see, 3, 7, 8, 9 meters. That could be an actual hallway. These right here are surface interference points, but that right there is a void. That's a void. And let's look again where the line is made, right here. 2, 1, right here, going up this way. Now let's look at R2, 3, 1 meter, which is right here, just to the south of 1, 1, and boom. All right, now you see a couple of more of these jewels here, which indicates a room. You see the low numbers here, and up through here there's a low numbers, but right there and right here, all of that is void. That is a cavity. That's either a large room or a hallway or a crick in a hallway. It is an open cavern, and it appears to all of these appear to be about 12 and a half feet below the surface. Now we're looking at the fourth line, 1 meter at R2, and you see the low numbers. Here's a couple of jewels, which could be reflections off of one of the other voids, or 2 or 3 of them. And look at these numbers in right here. This whole piece here. Now this is surface interference here, but look at this right here. This is way up in the thousands. Anything over 1750, 1800 is a void. We proved that with our control in the last video. Here's all the settings. Everything is fine. And we see this cavity here, this cavern here. This proves there is a cavern there. Now let's look and see where that line is taken from. This line is shot. The 4, 1 meter goes this way, across this way here. So if we're seeing something there at 4, 1, what about 5, 1? What about 5, 1? Let's see what 5, 1 has to show us. Okay, here's R2, 5, 1 meter. It's going uphill. And look at these numbers here. Here are our jewels. 2166. Anything over 1750, 1800 is a void. And you can tell that this is probably 10, 12 feet down below the ground here. And this is just an absolutely excellent profiling job here. I gotta hand it to my crew. We did an extremely good job. So let's look back at where that one is shot. 5, 1 meter is up here. This is 4, 1, 5, 1. Now we're going to look at 6, 1 meter. Now you'll see right here we have something, and this right here could be interference, but is it? Let's see. We're going to see here. Here's some more jewels, and here appears to be an extremely large distortion here, and it's all over 1800. Goes up. That's what you have to look at, is the resistivity numbers. This is 6, 1 meter, and this is taken starting like at the funnel bowl, which is right here. Here's the funnel bowl, and here's where 6, 1 comes across this way. So as the ground rises a bit here, it crosses over all these lines here. Let's see it again. Boom. See, here's your little hump, and here's where it goes over. That right there appears to be some type of passageway. And remember, this is all solid sandstone. Sandstone does not create caves. There are not caves that exist in sandstone. Caves are indicative to limestone and perhaps granite, but this is all sandstone. Caves do not naturally occur in sandstone. Now we're going to show the 2 meter slats that we did in R2. This is 1, 2 meter. And so here you got twice the distance, maybe 180 feet, 185 feet maybe. And you're going down farther also. from here to here. It looks like about maybe 10, 25 feet or so, handsomely. And here's, of course, all the same information here. And then look at the numbers here, how they jump up right here. This is 1407, and boom, right there, under that color there. Now that right there is a surface interference, but it jumps all the way up to 4626 right here. Boom. And so what do you have right there? That is an opening. That is an opening on the R2 2 meter. So let's see where that line is shot. You can tell the grade. It's right here. 2 meter goes out this way. And you can see where that big cavity is right there. And this right here is number 2 meter, which we're now going to look at. So look at it. This is 2 meter. This right here is a surface interference. And when you're working with the 2 meter distance between the probes, you're going to be missing that little white line right there. That's a good representation of 6 feet. It's not going to show up. I know. But look right here. You have all this yellow, which is nothing. And then you have the brown moving up, but boy, does it come quick right there. That right there is a cavity. And now we're going to look at R2 2 meter. You're going to see here is some surface tension here. And look at these numbers right here, where they right here at the just below the yellow, and boom, it jumps up through the roof right here. That's sitting right on top of some kind of opening in this cavern system. And here's our jewels again. Now let's see where 2 meter is at here. 2 meter starts over here close to the stream bed and goes up and goes around this way. Like that. Goes right over some of the other high points. There it is again. Right on top of some kind of hallway, a corridor, large room, you name it, or a series of rooms. Now we're going to look at R2 2 meter. And here again, there's not a lot of surface interference here. But you see that right there, that corridor there, and then check that out. It's over 10,000 on the reading. That is a cavity. That is an opening. Now I'm going to show you where that line is at. 2 meter is this line coming down this way here. They said, well, why couldn't you do more of that? I had enough information to go on anyway, and I had other lines to cut, but this right here was just too rough and in really bad shape. The land was in really bad shape. It would have been really hard to get in there, and I just did not have time. Like I say, I'm only shooting 3 lines a night, tops, and that's only when I can get out there. So there's 2 meter again. Beautiful, spectacular. I just get excited when I see this because we nailed it. We nailed it. And there's no one that can argue with this machine. This is not a voodoo device. So that finishes us in R2. And now we're going to go about 750 feet to the west and look at what happened in R1. Here's the nomenclature for my wall map of R1. Same grid, 1 inch equals 10 feet. Now we're going to look at the overview here. There it is. This is the ravine here. And I shot the lines to the northeast, because that's where we had indicated with previous lines that were shot that we actually had something. So this needed to be gridded off. I had to clear out a lot of small trees, and I did that as best I could before the actual testing went, before the machines arrived. And here's the R1 stream bed coming down here. That right there is the waterfall that you saw in the last video. And here's a blow up. And you're going to see R1 1 meter here coming this way. And you're going to see 7 1 meter here. And this is 9 and 10. Okay, now, as I stated before, I didn't have so much enthusiasm for people going into R1 with me. That everybody was concentrating on R2, and I knew that I had to do R2 in a very thorough fashion. So, on occasion, I had one guy go with me to R1, and we shot 3 lines this night. And this is the line. This is R1 1 meter. Okay? Now, here's your subsurface interference right here, up right there at the surface line. And look at what you have here. And look at the numbers. 227,000. And look at how high it jumps from the green to the yellow to right here. Wow. That is either a corridor or a huge room. Something was there. Well, funny thing, the other 2 lines that we shot that night, they didn't turn out. All these colors were just all meshed in, and it was all just screwed up. And so I thought, well, you know, I mean, I didn't know what to do. I didn't know what to do. So the next day, when this right here was iterated and run through the processing, and the slack came out, the phone was ringing off the hook with volunteers wanting to go into R1. Everybody wanted to jump. Hey, there's something in R1, which me and Paul have always said. Whatever is in one of these ravines, we're saying, and we have for, what, 25 years, that Alexander the Great, Queen of Queens Cleopatra, the entire Ptolemaic dynasty is buried in this ravine system. Well, the ravines are only like 750 feet apart. There's got to be something in the other ravine. Regardless which ravine they are in, there's something in the other ravine. And this proved that there was something underneath the surface in R1, just northeast of R1. And you can see here, it's probably what, about 12, 13 feet here. Boom. Boom. So what happened was, like I said, the other 2 lines that we shot that night, they didn't turn out. They didn't turn out at all. So I spent that day cleaning the connectors. I had CRC. I was spraying and cleaning out the connectors, and because I thought maybe there was something loose or something wouldn't make good contact. And went out the next night with a couple of volunteers this time, and we shot 3 lines, and they did not turn out. So I missed 5 lines. So basically, we went back out after I cleaned all the probes and cleaned up all the connections, got everything good and tight. Went back out the next night and shot 3 lines, and they were all just poo-poo. There was nothing there usable. It was just atrocious of what had happened, and something was wrong with the system. And so I called down to Marcus and the crew down in Austin, and I explained to them what had happened, and they had me run a diagnostics test out of the brain. I had to go and set the unit up out in the yard, which took me about an hour and a half to do by myself. I didn't have to put stakes in the ground. I just had to connect the probes to the box and string them out, and did a diagnostics, and they determined which cable, by the readings, that one of the cables, see these cables tie in together, and the cable's got like 3 or 4 probes on it. I can't remember exactly. One of the cables had gone bad, which means that 4 of the probes were not working. They were dead. So they said, okay, you take that one out, and you can't just move them around. It has if you take out like 4, 5, 6, 7, 8 on a certain cable, that's exactly what has to be put back in, is a 4, 5, and 6, and 8 from another unit right there. In other words, you can't take 9, 10, 11 and put there where 4, 5, and 6 are. It's all, you know, electronically balanced out. So they were going to send me FedEx the replacement cable, and I was going to pull the cable out of where it was in the line there, and so I'd lost actually 2 evenings, an evening and a half, and I was down a day, and I was like, well, you know, I mean, the time and money, it was AGI and Marcus, were they going to compensate me for the day that I'd lost, for the 2 days that I'd lost? No. What they did was they gave me 2 more days and allowed me to purchase 2 more days at the cost of 1, which I thought was more than fair. And so as soon as the cable came in, and I believe it was raining, so you don't want to use this unit in the rain anyway. I think it was a shower that one night, so we was going to lose it anyway. And I put the new cable, replaced it, and the machine worked fine. And so we are now back into testing in R1. And R6 was done farther south, and line number 6, 1 meter, was done farther south, and so was line number 8. So the actual one that we got here on the grid here is going to be R17 1 meter, which is this line right here, starting here and going up this way. Okay, now let's see if we can see it better here. Yes, here's a 7 1 meter here going that way. Okay, so what did the 7 1 meter show us? High numbers all over again. Look at that. It's either right on top of a huge room or right down the corridor, and the joules are not uniform. That was an opening. Picked up again. 9 1 meter. Look at these numbers through the roof. 2 huge joules here. Well, look at that. All of this is open cavern, open caves, right here. Now let's see where that shows up here on our map. 9 1 meter comes down this way here. And while I'm at it, here's 10 1 meter coming in this way. Look at where all of these are. This is 10 1 meter. 51,384 right here, and it's not even finished. That right there is most likely a surface interference. But this right here, it's not. Moving forward to R1 11 1 meter, and look at the numbers, 16,000. Remember, right here is where the actual caves and openings and voids, anomaly or voids, start right in here. All of this right here below, all of that is wide open void. And this right here is 11 1 meter, right across there. See, so I would shoot 3 lines, we would look at them, and I had my plotted maps. These maps here are totally refined, but we knew where to shoot. I knew where to shoot the lines accordingly. Now we're going to look at the 2-meter lines that were shot in R1. And this is all in 2000. October of 2000. And again, the line is probably, what, 185, 186 feet long. And you see right here in the center what you got there. Boom. Super high numbers. Very little surface interference here. Look at these numbers here. Okay, so now we're going to look and see where that line was shot. And the 2 meter starts way up here and comes down this way and ends right here. So it goes over our hot spot and shows what appears to be a huge room. Right there. Next is the 2 meter. And you see these high numbers here, and they're starting at this color here. Boom. What that is, I don't know. I just know that the numbers are high and it is a good reading. That is some type of cavity. Could be a niche. It's something underneath the ground. So I'm going to show you where that line was shot from. And 2 meters starts here a little ways from the cleft in the ravine there, from the bluff, and goes up this way like that. So now we're looking at R1 3. This is the 3rd line at 2 meters. Look at these high numbers. That means there's something here and here. Remember, this has got to be what, 12, 14, maybe 16 feet below the surface, right here. Appears to be what, 14 feet wide. So we're going to see where that line was shot. Starts right here. The 2 meter starts right there and comes across this way. So what I'm doing is I'm crisscrossing all the patterns here. This is the blow up of it. This would be number 1, number 3, number 2 coming up this way. But I wasn't satisfied. I still wanted to shoot a 3 meter line in R1. I was going to have to go back out, and it was a stormy night. We slipped in and we got our testing done, and then we had to pack up and go, and that was the last night that we could shoot anything. So we shot the 1 meter, starts down here and goes up this way, way up this way here. Now let's look at what it had. See these high numbers. Shows something here, shows something here, but you see this right here, and it just cuts right off there. The guys at AGI, they said that that has to be a man-made wall of some sort, of some kind. They had never seen anything like it. The only thing that they had seen that was similar was ancient ruins from someplace unknown. They couldn't remember, but they had seen ruins buried in the subsurface where they had something like that right there. Now, it's not just a boo-boo with the dark color here, way up in the thousands, probably around 20,000 or so. It's all the other subsequent colors backing it up here. So this is not a mistake, and boom, it's got a jewel right over the top of it. So that concludes the presentation here. We're going to look again at how all of these in R1 coincide, and this proves unequivocally what appears to be a large room underneath the soil of R1 and a cavern system in R2. And that concludes this presentation. This is probably the most technical video I've ever done, but I had to make it to where you could understand it, and now you have become a geologist and you know all of the subsurface anomalies in our target area. Thank you.